time. It's time for me to start there. Hi, Spencer.
Hello.
Okay. Anything you need?
I have a question about the quiz.
Okay, I can get there. Okay. Let
So
me.
it's, sorry.
Right. No, I'm trying to.
Let me turn this music off.
Okay, not that. That's what I want. Okay, I'm in. Are you seeing the screen now, Spencer?
Yep.
Okay. Okay, I'm getting into quizzes. Do you mind if I show yours?
Yeah. No. Sure. Go ahead.
Which one is it? 14? Nope.
No, the recent, the 13.
13. Okay.
I mean, yeah, that one.
Hi, Victoria.
Hi.
You look like you just got up.
No, I just got home from work.
Same difference.
Yeah, exactly.
Okay, one second. I'm trying. Spencer asked me a question about the quiz, and I'm trying to find his quiz so I can talk about it. You didn't do that bad, Spencer.
It was one of the questions which I was, number 9, I think it is. It says, the limiting reactant for number 9.
I got it. Go ahead. I got to go ahead.
Oh, you got to do it.
Can you hold on a second, Spencer?
Yep.
I'll be right back. Sorry, I just realized I didn't have a periodic table. All right. So we got, first of all, we recognize this is a limiting reagent problem, right?
Yep.
Because you have 2 amounts of the 3 things. Okay. So you got 28 grams of potassium thiocyanate. Potassium weighs 39.10. Sulfur weighs 32.06. Carbon 12.01 and nitrogen 14.01. That should be everything, right?
Yep.
So I get a total weight of 97.18 molecular weight for the potassium thiocyanate, correct?
Mm-hmm.
All right, my iron chloride. I got 3 times 35.45. That gives me 106.35. And iron is 55.85.
Okay.
So for that, I get 162.20. Right?
Mm-hmm.
All right, 28 grams of potassium thiocyanate times 1 over 97.18. All right, that equals 0.288 moles of potassium thiocyanate. And if I'm looking to see how much KCl I can make, it's a 3-to-3 ratio, right?
Mm-hmm.
Spencer?
Yeah.
It's a 3-to-3 ratio. So that means I can make 0.288 moles of KCl using my potassium thiocyanate, right?
Yep.
I use 18 grams of ferric chloride times 1 over 162.20. That gives me 0.111 moles of iron chloride, iron 3 chloride, right?
Mm-hmm.
But that molar ratio is 3-to-1. Okay? So
Okay.
if I have my 0.111 moles of iron chloride and I multiply that by 3-to-1, because I make 3 moles of potassium chloride for every 1 mole of iron chloride, that gives me 0.333 moles of potassium chloride, right?
Yeah.
I could make 0.288 from the potassium thiocyanate. I can make 0.333 from the iron chloride. So the case SCN should be the limiting reagent.
Okay. So why was that marked wrong then on question 9?
What are you talking about? It wasn't marked wrong. It wasn't marked wrong. Sometimes, Spencer, what happens is I put the answer in, and when I put the answer in, it doesn't save it for some reason or other.
Okay.
So you got credit for it. You now got 8 out of 10. Happy,
Okay.
happy?
Yep. I was just wondering because I was sitting there looking at it. I was just like, if I got number 10 correct and number 8, then how did I get number 9 wrong?
Yeah. What can I tell you?
Okay.
You're good. It may have been a total screw up on my part, and it may have been just what I said, that I had to write it, I had the wrong answer, and when I went to change it, it just didn't save it.
Okay. And when are you gonna put in the pop quiz? I'm not sure if you already have for some people.
I should have.
I haven't gotten mine in yet.
When did you turn it in? Did you turn it in on time?
I turned it in a day late.
Then did you email me that you turned it in?
I did.
Okay, then I will get to it.
Okay.
As a matter of
you.
fact, I can get to it now. Victoria, do you have anything?
Nope.
You're just here early just to be early?
Yeah, surprisingly.
Okay, good enough. I'm going to go back and I'm going to try and, first of all, I'm going to give Spencer his points. All right. Okay. Quizzes. All right. Spencer, I've got you a 10 of 10.
On the
Pop quiz.
grade book, it doesn't have it marked down as anything. It just says dash out of 10. I'm not sure. On the when I go to my grades, it just says dash out of 10, as nothing was put in.
I'll look and see what I have, but
I mean, I can double check to see if mine was posted real quick.
Victoria, you put it in on time, so it was graded with the others.
Okay.
Nobody's grades in there. Thank you,
Yeah.
Spencer. I have to figure it out.
You're
I have to
welcome.
figure out why. Oh, I know why. It'll be in there in a second. There's
Okay.
one button I need to push. There's a button in here that automatically puts it over to the grade book. And that I'm sure has not been done. Now, Spencer, if you check, it should be in there. Is it?
Yep, it is.
Yeah, that's basically what happened was there's a button that I have to push that automatically exports the grades to the grade book. And that wasn't pushed in that instance. Okay.
Okay.
So I have to, one of the things I have to do is I have to regrade quiz 13. Thank you, Spencer. You get a point.
Thank you.
You got a point for correcting one of my errors. Numerous that they may be. No, that's not what I want. Yeah. And okay, Sanders. That's your first extra credit point. Not you, Victoria. You've been piling them up. That's Spencer's first.
I
Anybody-
was celebrating his excitement.
Oh, he's just overwhelmed. I mean, it's
Yes.
just it is just overflowing here.
If he woos, I'm gonna join in the celebration.
Woohoo.
Lose for everyone.
Anybody have any other questions? Good time to ask them, guys. Okay. I got nothing else for you. Everybody doing okay?
Yeah, how are you?
Tired. I'm really, really tired today for some reason or other, which is really disturbing because I have to teach face-to-face classes tomorrow.
Ew.
What do you mean, eh?
I did my time with face-to-face classes when I was in college the first time. I kind of like Zoom and online stuff a little bit better.
Really?
Yeah.
See, I hate it because I can't see, for the most part, I can't see your reactions.
That's true.
I mean, I can't, it's that sea of dumb looks that I'm looking for.
I understand that. I think since this is my second time going through college classes, I'm like, yeah, just here for the class, I guess.
Well, you have an advantage, a couple advantages over some of the people you're taking this class with.
Yeah.
And literally speaking, by the time I graduated West Virginia University, I remember specifically walking down this road and thinking, you know, I can kick the shit out of any class this university has to offer. And that was basically the truth. There was really nothing that they could have thrown at me that I couldn't have, if I'd have studied hard enough, couldn't have gotten an A in.
Right.
So it's a matter, by the time you get a little older, you get to know, hey, you know, maybe if I really give the professor what he asked for, maybe I can get a good grade.
Yeah, that's kind of what I figured. I'm like, just do what they say and you'll get a good grade.
Amazingly how much that works, guys.
Yeah.
It is really, really amazing. How you doing, Aaron?
It's
Uh,
going.
it's going.
It's going. That's it.
Uh,
That's all I got.
that's all you got today?
Mhm.
Go buy a puppy. Puppies always make you feel good.
I could do that, but I still live with my mom.
Any cats in the house?
Yes, I have 2 of them.
Then you may not want to buy a puppy.
Yeah.
How's it going, Hunter?
I've been trying to get my car situated today. I've been running all around.
What's going on with your car?
Something's up with the transmission. It's been at a transmission shop for a while. Then I found out that Ford suck, but I found out that Ford offered an extended warranty, so I took it over there. So I had to pay like $500, and then now I gotta. Hopefully, the problem will be solved over at Ford, but I'm waiting on the tow truck driver to call me because they're supposed to pick it up over at the place in about 15, 20 minutes.
Yeah, believe me, I know about car troubles. I was in, at Thanksgiving, I was in South Florida, and my car picked up a stone in the radiator.
Oh my gosh.
So basically, for a week and a half, I had to leave the car in South Florida while they waited for a part.
So obnoxious.
Yeah, it was amazing.
And I'm trying to break these savings goals, but it seems like every time I achieve a significant savings goal, something about my cars just makes me cough up some money for it.
You know, Hunter, that's God's little way of saying you have too much savings.
Oh my God. Never be too much.
Yeah, it's like it's a great line from Richard Pryor. Richard Pryor said, cocaine is God's way of saying you're making too much money.
That's funny.
How are we doing, guys? Anything else? Anybody have anything for me? Any questions? Nada. I got nothing. Who else is in here? Jennifer, you're in here, aren't you? Marie, how you doing, Marie?
Doing good, thank you. How are you?
PhD King, wonderful. Just happy to be here.
Okay.
Aren't you? Marie, if you could be anywhere else in the world, you would rather be somewhere else than here? She's not answering. I think she doesn't want to upset me.
No.
Well, I'm just checking into hotels in Savannah because, guys, my semester ends on May 10th. May 11th, I'm on my way to Savannah for 4 days.
Oh, what are you doing there?
Anything but teach chemistry.
Yeah, right. As soon as you look at some natural substance out there, you're gonna start counting coefficients and stuff.
No, I'm not, Hunter. You don't know
He
me
won't
very
do
well.
chemistry, he'll start doing physics.
Guys, you don't know me very well.
Oh, look, there's some sucrose on the ground.
Why do you think I went back and got my English degree?
Are you gonna do like
Your point.
a tour, a history tour, literature tour, maybe?
Nope. I've been to Savannah probably about 3 or 4 times. I just love the city.
Oh,
It's a great place to be around.
you can go on a
Especially-
ghost tour.
Oh, that's a good point.
You know, you may
Ah.
not believe it. There's still history involved.
Have you been to
Listen.
Helen, Georgia?
No, I haven't. Aaron,
That's a
Aaron,
great place.
1 second, Hunter. Aaron, did you want to say something?
Yes. So I went to Savannah with my Girl Scout troop and we ended up doing a ghost tour. It was absolutely amazing. You get to learn a lot about the dark history of Savannah.
They
Like
used to
not
have-
just
Shanghai there. There was one,
The Shanghai Underground or whatever
Yeah.
it was called. Yeah, I know about that.
no, you're absolutely right, Aaron. And we'll have to see how much time I have. But there's a lot of art in Savannah. And it's like one of the best art schools in the nation is the Savannah Art Institute. So lots of good food there. Lots of jazz, man.
Yeah, there's a lot of seafood.
Absolutely. But they have two fantastic, absolutely fantastic jazz bars. And when I go to a city, I like a city because of history. I like it because history, culture, and just food and food. Those are the three major things I go by to critique a city.
You're
And
gonna
then
go swing dancing?
Nah, not swing dance. It's a different kind of jazz, Hunter.
Oh, gotcha.
Uh,
You got barbecue over there?
Little bit, not much. I mean, if I was going to go to a barbecue,
Tennessee.
Oh, now I'm hungry.
Memphis is a good place. Kansas City.
Oh,
I
yeah.
actually like South Florida's barbecue. But
I love like Spanish food. That's why I love Florida so much.
are you talking about Spanish or are you talking about
Just like, you know,
Cuban and
Cuban,
All of it.
just all of it. You know what I mean?
All of it.
Latin.
man, I was in Spain once and I had this tapas of oxtails. Oh my God. Yeah, you just turned your nose up, Hunter.
Oxtail.
Oxtail was phenomenal.
My fiance's cousin knows how to make like an oxtail soup. It's
Oh,
yeah,
Oh.
menudo.
I heard they got a really interesting architecture in Spain because a lot of the like Christian churches and stuff are built on top of like mosques, so they have these like interesting
the
layouts.
Alhambra.
Yeah,
There's this
I took
one.
humanities.
There's this one mosque that's so huge that the cathedral is just like in 1/10 of the location.
It's crazy.
Okay, guys, I'm sorry, but we got to start doing what we're here for. It is 5:30. Anybody have any questions? If you have a question about quiz 13, question 9, the answer was wrong, it will be regraded. Okay? I had the wrong limiting reagent. All right. Okay, guys, we're going to get into this and we are going to share screen. Oh, I got to stop share before I can share what I want to share. Okay. That looks good, Victoria.
Listen, I have no shame anymore of just eating on camera. I just don't care anymore.
Me either.
All right, let's do a simple problem first to get kind of our muscles working. I have 39.45 grams of copper chloride, and I have an excess quantity of aluminum. How do I solve this problem? What do we do, guys?
Isn't this the same question in the forum?
In the forum?
I know I've done this question today in this class.
All right. You want me to make up a new question? Okay.
No, I was just asking.
All right. I'll make up a new
No.
question.
Yeah.
Just for, who's this demanding person? That is
I wasn't demanding anything. I was
absolutely-
just asking.
Who is the demanding person that is?
That's Mariah. Listening.
Let me see. I have to think about. Yeah, let's go with FE. Okay, we'll go with copper. Yeah, this looks good. Whole new question, guys. I'm sorry, who was complaining? Was that Marie? Who was complaining
It's not
about doing this?
complaining. It's just I was just wondering because I thought I had just done that.
A different number, okay? Well, since you've already done it, what do we do?
Well, I technically did the other one. I haven't. You'd go grams to moles.
Grams to moles. So I'm going to take my 39.45 grams of CuCl2, and I'm going to multiply that by I'm going to multiply that by, what am I going to do here? What am I multiplying it by?
Uh,
The molecular weight.
yeah, 1 mole over the
One
molecular
mole
weight.
over molecular.
Okay, the molecular weight, copper is 63.5. Is that correct, guys?
Yes.
The molecular weight is 134.4.
Okay, I'll trust you on that. All right, I divide the 39.45 by 134. Sounds about right. So I get 0.294 moles of copper chloride. Now what do I do?
Molar ratio.
What is the molar ratio?
The 2 moles of FeCl3 over the 3 moles of CuCl2.
1 to 2.
Not 1 to 2, Hunter,
2 to 3.
2 to 3. Hunter, do you see the 3 in front of the copper chloride?
Oh, sorry. Yeah. Okay. Yeah.
Oh, no, don't do, this gives me 0.196. All right. Now what do I do? Come on, what do I
Moles
do
to
now?
grams. Moles to grams.
How do I do that? You don't have to know the exact numbers, just tell me.
Oh my.
Somebody, one person. What goes on top here?
1.
Molar mass.
Molar mass, not one. Who's got
Marie.
Marie?
Yes, molar mass of the compound.
Okay, Marie.
Yes.
I want you to mute because thank you. I'm getting an echo, Marie. It's driving me a bit bonkers. So I got 162.2 grams divided by 1 mole. And this ends up being 31.8 grams. Okay? Simple enough, guys. 3-step process. Change the grams are known into moles. Use the molar ratio. Use the molar ratio to turn the moles of the known into moles of the unknown. Then as a 3rd step, we are going to take the moles of the unknown and turn it into grams by multiplying by the molecular weight. Easy peasy, guys?
Yes, but sometimes the questions are very confusing.
In what way, Marie?
1 second, I would one of them somewhere.
If you give me an example.
When I find it, I'll tell you.
All right, fine as kind.
Okay.
Okay. We have 1,816 grams of oxygen and 604 grams of octane. How many liters of carbon dioxide do I generate at STP? All right, what kind of what kind of special stoichiometric problem is this?
The one that
Recognition,
is up
guys.
For the title.
What's that?
It says it for the title. Limiting
Absolutely.
reagent.
Hey, I didn't say it wasn't obvious. We're dealing with a limiting reagent problem because we have an amount of both reactants. So we got to find, first step is find the moles of both. I got 1,816 grams of oxygen. I multiply that by 1 mole of O2 over 32. Now, an important point I want to point out here for you. Do you remember what we used for oxygen in empirical formulas? What was the weight we used to make moles of oxygen in empirical formula problems?
The atomic weight.
We were using 16 because we needed to get the moles of the atoms. Here, we have a molecule of oxygen. So when we are doing stoichiometry, we use the molecular weights of the diatomic molecules. Empirical formula, you use the atomic weights. Stoichiometry, you are going to use the molecular weights. So I go through, I divide 1,816 by 32, I get 56.75, 604 grams of octane. The molecular weight is 114. I get 5.30 moles of octane. Jennifer, are you a betting person?
Not really, no. Scares me.
Who's betting? Who's a gambler? Who's a gambler out there?
This is where no one wants to admit that they may have a
Yeah.
gambling
No,
addiction.
we're all broke students.
There we go.
Kaylin, look at those two numbers. What's my limiting reagent? What do you think is going to be my limiting reagent?
Don't we need to do the molar ratio first?
Thank you. Very good. You're absolutely correct. But just looking at those two numbers.
Oh, okay, okay.
Just looking at these two, which would you suppose is going to be the limiting reagent?
The 5.3.
But remember, our molar ratio of oxygen to carbon dioxide is 16 over 25. Our molar ratio of octane to carbon dioxide is 16 over 2. So if we do those two molar ratios out, lo and behold, from our 56.75 moles of oxygen, we can only make 36.32 moles of carbon dioxide. From our 5.3 moles of octane, we can make 42.4 moles of carbon dioxide. Now, Kaylin, which one is my limiting reagent?
The top one.
All right, guys, I did this example very specifically to tell you, to show you why you can't just stop once you get the moles of each reagent. You have to take it, like Kaylin said, you have to take it to the next step. You have to take it past the molar ratio stage before you can choose which is the limiting reagent. In this instant, my oxygen is limiting. So I now have moles of CO2. The question is, how many liters of carbon dioxide do I generate at STP? Do I have any relationship?
Yes.
What is that? What do I have to do to the 36.32 moles of carbon dioxide to get liters?
You have to, excuse me, you have to take the smallest number and you have to times it by, or your limiting reagent, you have to times it by the 22.414 liters.
Remember, absolutely correct, Victoria. What we're doing, we have a relationship between liters of a gas at STP in moles. 1 mole is equal to 22.414. So all I'm going to do is take my 32.32 moles of carbon dioxide, multiply that by the molar volume, and I get 814 liters of carbon dioxide. For the most part, guys, this has been a little bit of review for what we did on Tuesday. Is everybody on solid ground? Anybody have questions about anything?
Yes, if you go back a slide, where did you get the 2 moles octane?
Look at the, sorry, 1 second. Look at the balanced chemical equation. I'm sorry, who's speaking?
Chase.
Chase, okay. Chase, look at the balanced chemical equation. We're dealing with the molar ratio, right?
Yeah.
So the molar ratio between oxygen and CO2 is 16/25. For octane, it's 16 CO2 over 2 octane.
Okay.
Are you seeing that, Chase?
Yeah.
Anybody else? Okay. I'm going to hold off on this one. I actually probably should have just done this one rather than another one. It's just another simple, easy. All right. New concept here. Determining percent yield. Percent yield is what you get back divided by what you should have gotten back. It's the amount you're going to actually be doing the reaction experimentally. And you're going to actually figure out how much the experiment produces. You're going to divide that by the amount the stoichiometry predicts. And then multiply that by 100. Amount retrieved is the amount the actual experiment makes. The predicted amount is the amount that stoichiometry tells you you should get. You mix 5.034 grams of sodium phosphate with excess nickel 2 chloride, and you get 4.583 grams of sodium chloride. Is this a limiting reagent problem?
No,
Why not? I got 2 weights.
but we have excess nickel.
Very good, Kaylin. Very, very good. I tell you straight up, I've got excess nickel. So if I've got excess nickel, that means my sodium phosphate is my limiting reagent. So what's the 4.5, Kaylin?
That's the product.
How did I get the product?
Oh, I don't know.
I actually mixed up the 5.034 grams of sodium phosphate with the excess nickel chloride. And I did this experimentally, and I ended up with 4.5 grams of sodium chloride. Fair enough? Kaylin?
Yes. Yes, fair enough.
All right. So when you see something, when you see the English language, obtained, you got, you produced, that means that you actually did the experiment, and that is the amount that you actually did receive back from the experiment. Is that clear, guys? Now, if I want to know the percent yield, I have to figure out how much 5.034 grams of sodium phosphate should produce. So I'm mixing nickel chloride with sodium phosphate. It was nickel 2 chloride. Is the nickel chloride balanced?
Yes.
Nickel 2 chloride, Victoria?
Oh, no, sorry.
Somebody balance it. I'm agreeing it's not balanced.
NiCl2.
NiCl2. How about the sodium phosphate?
Sodium is a
No.
+1. I think phosphate is a -2.
So it would be
Three.
Na3PO4.
Victoria, PO4 is a -3.
Yeah, I had to go and look at it again. It's been a while.
So it's Na3PO4. All right. Now, if Ni is a +2 and PO4 is a -3, what are the subscripts for Ni and PO4? Ni +2, PO4 -3.
Ni3
3PO4 2.
Ni3 parentheses PO4 2. What about sodium chloride? Is that balanced?
Yes.
All right. So I have my chemicals balanced. Next step, we've got to balance our equation. Are my nickels balanced, people? What do I do?
Put a 3 in front of nickel chloride.
Okay, how about my sodiums?
Three in front of sodium chloride.
Okay. Now I have 6 chlorines on the left. How many do I have on the right?
3.
Fix it.
So 6 for NaCl.
All right, I have 1 PO4 on the left, 2 on the right. Fix it.
2 Na3PO4.
Am I balanced?
Yes.
All right. I've got my final balanced reaction. Now, first step, I got to convert my reactant to moles. I have 5.034 grams of sodium phosphate. What do I do with that? How do I get moles?
You do 1 mole over the molecular weight.
Guys, I'm keeping on saying these same things over and over because I want this to be rote to you. I want you to be able to come up to these equations and not even think about what you have to do. You're absolutely right. Victoria, you got to take the grams of sodium phosphate, multiply it by 1 mole over the molecular weight, which is 163.94. I do that math, I get 0.03071 moles of sodium phosphate. Katie, what do I do now? Stoichiometry. First step is get the moles of the known. We just did that. What do we do after we get the moles of the known?
You turn them, no, not into grams. That just came from grams. I don't know, skip me.
Nope, no problem.
I just
Somebody help
failed the
her.
test.
We turn the known into moles. Then what do we do with the known moles of the sample?
Do you
Molar
multiply it by the
ratio.
mole?
Molar ratio. What is the molar ratio between my sodium phosphate and my, what do I want, sodium chloride? What am I
6 to
asking for?
2.
Sorry, I forgot what, oh, sodium chloride. What is my molar ratio between my sodium phosphate and sodium chloride?
6:2.
6:2. So I'm going to multiply my moles of sodium phosphate by 6 moles of sodium chloride over 2 moles of sodium phosphate. I get 0.09213 moles of sodium chloride. Hayden, what do I do now?
Do you multiply it by the molecular weight?
Multiply it by the molecular weight. So I get the molecular weight of sodium chloride is 58.44. So what I've just determined is that if I start with If I start with, where's it at? If I start with 5.034 grams of sodium phosphate by the stoichiometric powers within me, I just determined that I can make 5.384 grams of sodium chloride. This is what I should get. Looking back at the original problem, how much did I get back?
4.583.
So that's how much I did get back. Percent yield is how much I did get back divided by how much I should have gotten back. Experimental results divided by stoichiometry results. And if I do that, my last step is I'm going to take what I did get back, divide it by my stoichiometric results, multiply by 100. My percent yield is 85.12. Questions, ladies and gentlemen?
So how would we describe 85.12? Like if we were to put it in a sentence, how would we say that?
The percent yield is 85.12%. I can't put it any more simply than that, Marie.
No, I get that.
Was it Marie, Marie or Rosina?
It's Rosina.
Sorry, Rosina.
No problem.
So I'm not understanding your question then, Rosina.
Okay, let me sit on it. Thank you.
Well, sorry, try and ask it in a different way.
So yield is basically the production, right? But here we are saying what we actually got is what was produced. So the 4.583 was the actual quantity that was produced out of this chemical reaction.
Yes.
But according to our calculation, we should have gotten 5.384. So does it mean that we got only 85% of what we expected?
Exactly. Exactly. Okay, Rosina, you throw 20 socks into a washer, right?
Mm-hmm.
Don't you expect to get 20 back?
Yes, hopefully.
Hopefully. Sometimes you don't. Sometimes you get 17 back, right?
Yeah.
It's those little washer mongrels that eat up the socks in there.
Right.
So you got back 17, you expected 20. So your percent yield was 17 divided by 20. Your percent yield was 85%, just like this.
Okay.
All right. That makes sense, Rosina?
Yeah. Okay. Thank you.
Okay. How do you determine theoretical yield when you have an amount for each reactant? Simply speaking, guys, if you have an amount for each reactant, you got a limiting reagent problem. Your theoretical amount is going to be the amount you get from the limiting reagent. You mix 2.034 grams of nickel 2 chloride and 1.727 grams of sodium phosphate, and you get 1.583 grams of sodium chloride. What is the percent yield? Then we have another question on top of that. How much of the reagent in excess is left? All right, we have our balanced chemical reaction. So our next step is to take our grams and convert them into moles. Nickel chloride divided by the molecular weight, I got 0.01569 moles of nickel chloride. My sodium phosphate divided by its molecular weight, I got 0.01053 moles of sodium phosphate. I take it through the molar ratio step. My nickel chloride will produce 0.03138 moles of sodium chloride. My sodium phosphate will produce 0.01053 3159 moles of sodium chloride. What's my limiting reagent, guys?
Nickel chloride.
Nickel chloride. So I'm going to use my 0.03138 moles of sodium chloride to determine how much product I made. I'm going to multiply it by the molecular weight. This means I got back 1.834 grams of sodium chloride. I'm sorry, excuse me. This means I should have gotten back 1.834 grams of sodium chloride. Remember, stoichiometry is going to give you what you should get back. But I only got 1.583 grams of sodium chloride. So I simply put back around what I did get back divided by what I should have gotten back and multiply by 100. My percent yield is 86.31. Questions about that? All right. I had another question at the very end of that last problem. And that was, how much of the excess reagent is left? What did we say the limiting reagent was, guys?
The nickel chloride.
Okay, so if the nickel chloride is limiting, will there be some sodium phosphate left?
Yes.
Yes, there will be some sodium phosphate left. We got to figure out what's left. All right, we know how much of the product was produced, right? We know how much of the product was produced because how much of the product was produced because we determined that through the use of the limiting reagent. Correct, guys? We know that we produced 1.834. We should have produced 1.834 grams of sodium chloride. Correct, guys? All right. Making 1.8 grams of sodium chloride, that used up all of the limiting reagent, but it left some of the other reactant. Correct? So all I got to do is subtract the amount of moles used in the reaction from the total amount of moles produced by the reagent in excess, and I will have the amount of excess reagent left. So let's see what I'm talking about here. I'm sorry, I got to see what I'm talking about here. Okay. Originally, my limiting reagent was the nickel chloride, correct, guys? That produced 0.01569 moles of nickel chloride. Is that true? Come on, is that true?
Yes.
All right. Now, what I have to do here is I have to look at the molar ratio between, I'm trying to find out where the,
I think it's slide 85.
85?
Yeah, that's a closer one.
Thank you. Thank you very much. I have my chemical reaction here. I know how many moles of nickel chloride. That was all used up, right, guys? That's the limiting reagent. All of those were used up. Can't I figure out how many moles of the sodium phosphate were used up if I use the limiting reagent? So that's the strategy I'm going to be using here. And that ratio, sorry, 85. The ratio between sodium phosphate and nickel chloride is 2 to 3. Keep that in mind for the moment. Okay, now I've already determined I had 1.569 moles of nickel chloride. In order to completely react with the 0.1569 moles of nickel chloride, I used a molar ratio of 2 to 3. I need 2 moles of sodium phosphate for every 3 moles of nickel chloride. This means I need to use up 0.1046 moles of sodium phosphate to use up all of the 0.1569 moles of nickel chloride. Are you with me, guys? Kaylin, you're looking confused.
Yes, you have a typo is all.
What?
It's 0.01569 that we had. Now I'm with you. Thank you.
Is that it? Is that
Yes.
correct now? Okay.
Yeah.
So if I start off with 0.01569 moles of nickel chloride, I need 0.01046 moles of sodium phosphate to react with it. Does that make sense, ladies and gentlemen?
Yes.
Okay. When I originally figured out my moles of sodium phosphate, I had 0.01053 moles of sodium phosphate. I used up 0.01046 in the reaction. So because I used up that much, I have 0.0007 moles of sodium phosphate left. In order to determine the grams of the amount left, I take my moles of sodium phosphate left, multiply that by the molecular weight. That gives me the grams of sodium phosphate that are left. Strategy-wise, let's go back and see. Let's go back and analyze how we did this particular problem. Originally, we determined that nickel chloride was our limiting reagent. So that meant that some of our sodium phosphate was left over. So by using the molar ratio between my nickel chloride and my sodium phosphate, that molar ratio being 2 to 3, I was able to determine how much of the the sodium phosphate was used up in the reaction with the limiting reagent. So I have my limiting reagent amount. I multiplied that by the molar ratio. This meant that I had to use up 0.01046 moles of the sodium phosphate. When I originally did the calculation of sodium phosphate, I had 0.01053 moles of sodium phosphate, but I only used 0.01046. Sorry, I'm trying to find out where I'm at. Sorry.
I think you're going backwards.
Yeah, you're right. I am going backwards. Thank you. Okay. So when I used the limiting reagent, I found out how much sodium phosphate I used up. I originally had 0.01053 moles of sodium phosphate. So all I have to do is just subtract how much I used up. This gives me the moles of the sodium phosphate left. I simply multiply that by the molecular weight, and I have the grams of sodium phosphate left. Are we good, guys? This is not the only way to work this problem. What I could do is I could take the amount of product that I formed, take that back to find out how much of my sodium phosphate was used to make that amount of product, and then subtract that from the original amount. There are different ways to do this. I don't want to get into that. I don't want to go into different methods. What's left? Doing another problem of excess reagent. When I mix 5.445 grams of lead 2 nitrate with 10.233 grams of sodium chloride, how much of the excess reagent is left? Pick one. Pick a reagent. Let's see who's out there. Brian. Brian? Brian. Now would be a good time for me to take roll. Omar, you there? Omar. Lewis. Lewis. Christina. Gaith. Zaina.
Here.
Curtis. Terry. Apple Grace.
Here.
Hunter. Hunter, I know you're there. I talked to you earlier.
He said in the chat he's on the phone. I think
Okay,
he's-
Lewis.
Yeah.
Lewis. Marie. Jadania. Jadania?
Yes, I'm here.
I'm here.
Chase. Gotcha. Fabiana.
Here.
Leandre.
Here.
Armethea. Nyla. Nyla. Kaylin.
I'm here.
Aya.
Here.
Elizabeth. Kevin. Shamira. Shamira. Mariah. Mariah?
Here.
Aaron, I saw earlier. Rosina's here. Hunter is here. I'm sorry, Andrew Malik is not, though. Katie is here.
I'm sorry. I was on a phone
No.
call for a little bit there with the towing people. They're driving me absolutely nuts right now, but I'm back. I'm sorry.
No problem. Cash. Cash. Faith.
I'm here. I joined at like 6 because I was doing something. I'm sorry.
Mila. Don't worry about it, Faith. Mila. Mila?
Mila?
Mila. Sorry, Mila.
No, you're fine. I'm here.
Jennifer's here. I saw her. Alec. Alec? Brian, Helen, Spencer,
Here.
and Tori. Okay. All right. Spencer,
Yep.
which one of these do you think is going to be the limiting reagent?
The lead and the lead NO3.
Lead NO3. Okay. All right. If I've got 5.44 grams of the lead NO3, this gives me 0.01644. Molar ratio is 2 to 1. 2 to 1. Right, Spencer?
Yes.
Between lead and the sodium chloride. So if I have 5.44 grams of lead nitrate, I need 0.03288 moles of sodium chloride. Does that make sense?
Yes.
Come on, guys. This is the hardest problem in stoichiometry. If I have 5.445 grams of lead nitrate, I have 0.01644 moles of lead nitrate. I multiply that by the molar ratio of sodium chloride to lead nitrate. This gives me 0.03288 moles of sodium chloride. All right. I have 10.233 grams of sodium chloride. I multiply that by the 1 mole over the molecular weight. This gives me 0.1751 moles of sodium chloride. I need 0.03288 moles. Do I have it? Ponder that for a second. I'll be right back.
Hey, Professor.
All right.
Faith Patterson, there's the last name. She's asking to be let in the class.
No, I'm here. I'm here.
Oh,
Sorry.
wow.
Thank you, Hunter. Probably an old chat line, right, Faith?
Yeah, I texted that right as I opened up the Zoom, but I was let in almost immediately. So,
All right, ladies and gentlemen, got to get back to this problem. Okay? I
So
have
Professor, the 5.445 grams of PbNO3 gives 0.03288 of NaCl, while the other calculation we did, it has 0.1751. So then, does that mean the limiting agent
All right.
is PbNO3?
Okay. I got to sit here and work through the logic here. This is how much I need of NaCl, right?
Yes.
Rosina, that's how much I need of the NaCl with this much lead nitrate, correct?
Right.
Do I have it? Do I have enough? I need
Yeah, you have enough.
0.0328. Yes,
Yeah,
I
you
have
have enough.
enough. If I have enough of the other reagent, then the one I started with is going to be the limiting reagent.
Okay, got it.
All right. Now, this is the amount of sodium chloride that I do have. But if I have this much lead nitrate, I use up this much sodium chloride, correct? Guys, is that correct? So, to figure out how much is left, all I got to do is subtract how much I used from how much I originally started. This means I have 0.1422 moles of sodium chloride left. I simply got to multiply that by the molecular weight of sodium chloride, and that gives me the grams of sodium chloride left. So, another way of doing these problems, perhaps even simpler, is to take one of the two reactants. You're going to take one of the two reactants and you are going to assume it's the limiting reagent. And you're going to figure out how much of the other reagent you need to completely react with it. So what I did was I took the amount of lead-2 nitrate and I determined how much sodium chloride I would need to react with it all. Then I compared it to how much of the sodium chloride I had originally. I had more than I needed. If I had more than I needed, then the first reagent is the limiting reagent. What happens if I don't have enough? What happens if I needed 0.1751 moles and I only had 0.03288? If I took my amount of lead nitrate and it determined that I would need 0.1751 moles of sodium chloride, and I took my sodium chloride amount and determined that I only had 0.03288, which one would be limiting then?
The one that is less.
Go ahead, what?
The one that is less.
If I had more than if I didn't have enough to react with the first reagent, then the second one is going to be the limiting reagent. Try another problem. I don't know what. Can you see the whole slide?
Yes.
All right. I have this reaction. I've got 5.67. That's not what I want. Sorry, I'm just trying to sit here through. Let's make up something. I have 1, we're going to put a 2 here. That means we're going to put 3 there. We're going to do a 3 there. Is that balanced, ladies and gentlemen?
Yes.
All right. Hayden, pick a number. Give me a number. Hayden, give me a number.
3.
3.4
3.4.
or 5.
Okay.
Is that the grams of barium chloride or is that the grams of the aluminum sulfate?
The barium chloride.
Okay. Katie,
Yes.
give me a number.
7.18.
All right. How much excess is left? Somebody want to pick one, barium chloride or aluminum sulfate?
Barium chloride.
Okay, so you're saying the barium chloride is the limiting.
Mm-hmm.
All right, guys, when you're doing this, we are making an assumption. All right, we have to choose one or the other. Have to choose one or the other. Okay, so the first thing I'm going to do is I'm going to figure out if I have 3.45 grams of barium chloride, I have to figure out how much aluminum sulfate I would need.
I got 208.2, but someone could double check me on that.
Yeah. 208.23.
Okay, how many moles?
Ah, shit.
0.0165.
Round it up. Okay, so how much aluminum sulfate would I need? How do I figure out how much aluminum sulfate I would need?
You gotta find the
Do the
moles.
mole ratio?
Mole ratio. So I got to do 0.0166 moles barium chloride times, what is that? What is that molar ratio?
3:1.
Am I going to put the 3 on top or the 1 on top?
3 in the bottom and 1 on top.
I'm just doing this for simplicity's sakes. Okay, so that's how much aluminum sulfate I would need. How much do I have?
You have 7.18 grams.
I need to convert it to moles though, don't I?
Yeah.
I got 342.15 for the molecular weight.
You're absolutely correct. So how do I determine how much aluminum sulfate I have? Come on, guys.
Find the moles
How am I going to find the moles?
by doing 7.18 divided by 342.15.
All right. Do you understand this? If I have 3.45 grams of barium chloride, I need 0.00552 moles of aluminum sulfate. Do I have that much?
Yes.
And some more.
I have that much and more, right? So if I have that much and more, this means that my barium chloride is my limiting reagent. That means I have excess aluminum sulfate. So all I have to do is take the amount I have, 0.0210, subtract 0.00552. This gives me 0.0155. I multiply this by 342.15. And I have 5.29 grams left. Are we good, guys? Let's try. I'm going to copy this. We're going to use the same reaction. I'm trying to, all right. We're going to make the same assumption. We're going to make the assumption that the barium chloride is the limiting reagent. So we're going to do the same thing we just did. I'm doing nothing more than the same thing I just did.
I have 0.0008.
And we'll give it 800. So if I have half a gram of barium chloride, I need this many moles of aluminum sulfate. Let's find out how much I have.
I'm sorry, I'm getting confused with how you wrote that out. The one before that.
I just did it all in one.
So that's 2. Okay.
That better?
Yes, thank you. Sorry.
No problem. I'm going to change this number, guys. All right. Now, what I did was I don't know how that did that. All right, I took my 0.500 grams of barium chloride. I determined how many moles I had. Okay. Then I took the moles of barium chloride and multiplied it by my molar ratio. This is how many moles of aluminum sulfate I would need. Are we good with that, guys? The amount of aluminum sulfate I have was 0.00750 grams. So if I determine how many moles of aluminum sulfate I have, I divide it by the molecular weight. I now have 0.0000219. Do I have enough aluminum sulfate to react with all of the barium chloride?
No.
So which one's my limiting reagent now?
Aluminum sulfate.
All right. So if the one you picked is not the correct one, it's not the limiting reagent, then you have to kind of start to do the problem over again. In this instance, my aluminum sulfate is going to be my limiting reagent. So in that case, I got to figure out how much barium chloride I would need. All right, I know I'm not explaining this well, guys. And I apologize for that. All right, let's go back and analyze the problem. If you want to know how much excess reagent is left, you have to figure out which one is the limiting reagent. If I have two amounts, if I have 0.500 grams of barium chloride and 0.00750 grams of aluminum sulfate. If I think, okay, well, my barium chloride is going to be my limiting reagent. So if my barium chloride is going to be my limiting reagent, I got to figure out how much aluminum chloride was used up. So again, it's just a straight stoichiometric problem. Half a gram of barium chloride times 1 mole over the molecular weight gives me 0.00240 moles of barium chloride. I divide this by 3 and the molar ratio between the aluminum sulfate and the barium chloride. This gives me 0.000800 moles of aluminum sulfate. Now I got to figure out how much aluminum sulfate I have. I multiply my grams of aluminum sulfate by 1 mole over the molecular weight. This is how much I have on hand. I need more than I have. If I need more than I have, then the aluminum sulfate is going to be my limiting reagent. I now, since the aluminum sulfate is my limiting reagent, I got to figure out how much barium chloride that uses up. So I have my moles of aluminum chloride. I multiply it by 3 moles of barium chloride over 1 mole of aluminum sulfate. This gives me 0.0000657 moles of barium chloride. I originally had 0.00240, so I have to subtract the amount I used up. This leaves me with 0.00233 moles of barium chloride. I multiply this by 208.32 grams per mole. And this means I have 0.486 grams of barium chloride left. All right, show of hands. Who's confused as hell about excess reagent? Who's confused as hell, guys? Thank you for being brave, Katie. Katie, we're going to go and do this over again on Tuesday, okay? This is the first thing. This is the first thing we're going to go over again on Tuesday. Because I really need you to have a handle on this. Any questions, guys? All right, then. I will see you then on Tuesday. New subject matter. We're going to be doing solutions on Tuesday and acid bases on Thursday. Our next test is going to be a week from Tuesday, guys.
All right.
We're cranking it up to the end of the semester. I apologize for being a little disorganized tonight.
You're right.
Okay, guys.
See you in a bit.
I will see you again on Tuesday then. I'll see some of you later tonight.
Thank you. Good night.
Thank you.
Any questions? Helen, where were you? Helen? Omar, where were you?
I'm here.
Yeah, Omar, you have a tendency to go sneaking out in the middle of the class.
Sneaking out?
Yeah. If I take my roll at different times, you don't answer.
I'm sorry. I just had, too much noises around.
Okay. Cash. Same thing. Helen, are you there? Cash, are you there?
I got a question.
Okay, Omar.
So when is the last day for the semester, if you know?
I believe, I think the final is going to be, okay. Don't quote me on this, Omar,
No, I won't.
but I believe it's going to be the 6th of May.
Oh, okay. So it's not by the end, the semester ends in the beginning of May.
I believe finals week is the 3rd of May through the 6th of May. So our last class is going to be the 29th.
I see. The
All right.
29th of April.
29th of May, yeah, 29th of April should
Wow.
be our last class.
I really got no time to get all this done. Wow. So
It's-
for the homework, you said I can still do it, but
Yep.
for the past 2 ones, but you're gonna take grades, right?
Well, what happens is I believe it's 5% a day down to 80%. And then it doesn't go below 80%, Omar.
But I can
If
get
you don't
okay.
turn it in on time, for example, if homework was due tonight, tomorrow, biggest grade you can get is 95. Saturday, a 90. Sunday, an 85. Monday, an 80. Then it doesn't go below 80.
Oh, okay. Because I have, like, to be honest, I really didn't do a lot of homework like this semester, so I really have some past 2 from back and like in the beginning. So it doesn't go below 80, right?
Does not go below an 80.
All right, I'll try my best to get them done as soon as possible. I do
Okay.
apologize for that.
No problem, Omar.
Thank you.
It's out there for you to do.
All right, have a good night.
You have a good night too. Helen Cash.